All right, so in 15.1, we learned about piecewise functions. Today, we're going to learn about step functions. Step functions are a special case of piecewise functions. They are going to be in pieces, but they're not going to just be in two pieces like 15.1. So we're going to remember how to plot the following functions. F of x equals 6. Right, so that's like y equals 6. So, right, so that means the y coordinate everywhere along this line will be 6. So that is a horizontal line. And we'll be graphing horizontal lines, rays, and line segments today. So that's f of x equals 6. Graph f of x equals -7 on the same graph. Well, that's a horizontal line in which every point, right, that's the same as y equals -7. The y coordinate is -7 everywhere on the graph. Just like yesterday, remember we had the range could be an and or an or, although I didn't have a lot of examples. Hopefully we'll have more today. So to graph x is less than or equal to -2, we have a closed circle on -2, and we're going this way. X is greater than 4, open circle on 4, and we're going this way. That's a typical OR inequality. This is an AND inequality. It could be written as, right, x is greater than -7 and x is less than or equal to -3. You turn around that part, but it's 1, 2, 3, 4, 5, 6, -7 open circle, -3 closed circle, and it's always in between. Right, when we did AND inequalities, you could have, right, they either pointed out or they were in between. But as you saw in yesterday's lesson, if you look back, you can have it point the same way. It's just sort of silly because one takes over for the other. All right, so this is a step function. So notice it has 3 horizontal segments there, right? We have 2 rays, so it's in has 3 pieces, right? There's a piece that's green where x is less than 0. There's a piece where it's blue where x is between 0 and 3 there. It's in between 0 and 3. Now it includes 3 and not 0. That's why open and close circle. And then it has a third piece where x is greater than 3. So we can have more than 2 pieces to a graph. So a stepwise function is a piece function with a constant value in each section. In other words, horizontal little steps. It looks like a series of steps going up or down. So let's evaluate this step function. So notice, if x we're evaluating it for -2. So x is -2 less than 0 or greater than or equal to 0? Well, it's less than 0, so you'd say f of -2 simply equals -3. Whenever x is -2 or any value less than 0, the f of x, or the y coordinate, will be -3. Evaluate the function for x equals 0. Well, so we're doing f of 0. It says when x is equal to 0, then the function equals 6. All right, so evaluate. This is what a more typical step function looks like. It has 3 pieces. They can have 4 or 5 if I'm trying to make things more difficult. So evaluate the function for x equals -2. All right, so it's where x equals -2. So it's this middle one, right? Because the top one. So when f is -2, f of x equals +2, right there. Evaluate the function for x equals 4. So we're doing f of 4. When it equals 4, f of 4 equals 6. Right? So it's a series of horizontal lines, line segments, or rays, I should say. And so here's our first one. So for x is less than -2. So here's, right, here's -2 for x. Well, every point on there is at -2. It says that f of x is always -7. So in other words, right, y equals -7, because f of x and y are the same thing. So that's down here, right? There's y equaling -7. So it's going to be horizontal. So for any number that is any x that is less than -2, y is going to be -7. Of course, it's going to be an open circle because it's less than. Right? The middle section says if x is between -2 and +2, f of x equals 4, or y equals 4. So for this whole section, y equals 4 from between -2 and +2. I better graph that correctly. So from -2 and +2. And we have a closed circle at the -2 portion and an open circle on the +2 portion. Right? And now notice, we had this yesterday, right? These have to be, they both could be open circles and have a gap in the graph, but they can't both be closed circles because, right, if they're both closed circles, not a function, right, because it would fail the vertical line test. There would be two values of y for the same value of x. So if it's a function, right, it'll net one. If you have a closed circle here, the other one below it better be an open circle if it's going to be a function, right? This is f of x, that stands for function. And so then the third section is, I'm doing green, x is greater than 2, so when x is over here, y equals 6. So it's it says closed circle right there because it's greater than or equal to. So when x is greater than or equal to 2, y is always 6. And there's our first graph. Let's make it in different colors, be a little more consistent. And so these are very uneven steps. If you walked on them, that's not very nice. But this is a step function. So they're all going to be horizontal today, which makes it sort of easy. All right, so plot this step function. So for x is less than or equal to -5, that's there. Y is -3. So, and we're doing a closed circle. So anytime we're less than or equal to 5, whoops, it says +5. I was at -5, my fault. So we're over here. There we go. So we're at x is less than or equal to 5, y is -3. So closed circle, and then we're going this way. There's no magic, just like when we did and or inequalities, there's no magic about how long that arrow is. When we're between 5 and 7, so there's 7, the y will be 2. It'll be open. This one's closed. This better be open, and it is. And the other one's also open here. They're both open for this middle section this time. And then the last section, when x is greater than 7, y is 6. And it's a closed circle, and it's an arrow that way. Okay. All right, so domain and range. So let's look at domain and range. So domain, we have x could be less than or equal to 5, it could be in between the two, and it could be greater than 7. It's all real numbers. Now you could have a gap there, like if I forgot to put this, I'm not going to do this, but if I forgot the or equal to there, you would have to exclude 5, but all real numbers in this case. Every number is covered for domain. Now look at there is your range, right? The range is 3 numbers. Right? Y can be equal to -3, +2, and 6. It can't equal any other numbers. It can't equal anything in between those. Right? That's typical range for a step function. All right, so we're going to work backwards and write a piecewise function for this. So it's f of x. This one has 2. It's more like it's a sort of a combination of the two of yesterday, but it's horizontal, so I didn't want to cover it yesterday. And so over here, it's if x is, this is -3, if x is less than -3, and this one is if x is greater than or equal to -3. And right, we don't write y. This is a horizontal array, and so the graph of this one is simply 8, right? F of x equals 8 everywhere along there. And this one is 5. F of x equals 5 everywhere along there. In a lot of ways, step functions are easier, right? Because the slope of these both are 0. The slope of them all today is 0. So you're looking for the y-intercept, right? Or the y value everywhere on that ray. Those are rays. Let's do our domain and range. So there's no gap. So domain, x could be anything, all real numbers. Y can only be 2 numbers, and you can put them in either order. I should write y equals, though. Y equals 5 or 8, or 5 comma 8. Okay, so here's one where the domain is not all real numbers, right? Because we don't have any arrows going on forever here, right? So let's see that. So it's already graphed. We've already got the function. You're just finding the domain and range. Do that, please. Let's start with the range this time first, because that's the easy one, right? Y can only be 3 or 5 or 7, right? Now let's try to figure out what the domain is. Try to write it as simply as possible. Right, well, there's no way x is going to be over there, right? There's no way it's going to be over here. So it's between -4 and 8. And have we covered everything? As every possible value of x in between -4 and 8 accounted for? Yeah, it is. So now we need some symbols that show it's going to be between -4 and 8 for the domain. Well, we have a closed circle, right? So we're going to be, this is like an and. It's in between, right? X, even though it's in 3 different steps, x has to be greater than or equal to -4, or -4 is less than or equal to x, and x has to be less than 8, domain and range. Let's find the domain and range of this one. So once again, the range is easy, 2 and 4. What's the domain? Now this one has a gap, like an or inequality. Pause the video, figure out what it is. It should look like an or. So let's see. X is less than -4, or x is, I need an x over here. X is greater than or equal to 0, right? What it can't be is in here, right? It can't be between -4 and 0. We're going to write a piecewise function for that. Three pieces. One piece is if x is between 4 and 6. So let's do that. So it would be 4, and that's open circle, and that's, whoops, that's open circle, so no there, right? If between 4 and 6. This is if x is between 2 and 4. I'm running out of room here. I was a little, oh yeah, I don't need that. I'm going to rewrite this because I don't need all the room for this. I'm forgetting. So it's between 4 and 6 here, and it's if this is between 2 and 4, and the solid one is on the 4, and this is a comma, and this is if between 0 and 2, and it's very consistent here. It doesn't always have to be. All right. So if it's between 4 and 6, y is 7. If it's between 2 and 4, when this is f of x, that's floppy, and if it's between 0 and 2, f of x is 3. Okay. Domain and range. Well, the domain right? The lowest number we have for the domain is 0. The highest number for the domain we have is 6, and it's less, right? So x, it's open circle there, closed circle there, between 0 and 6. Range, right? Y can only be 3 numbers, 3, 5, and 7. Can't be anything else. So show on the graph why this is not a function. Right there, right? It fails the vertical line test. One of these closed circles right there at x equals 4, right? What you're showing there is that when you do f of 4, you could get two different answers. You could get 7 and you could get 5, right? That's totally not allowed in a function, right? This is a relation. It fails, everything is a relation, and it fails the vertical line test. Right, so we're practicing. So plot this. 0 to 3, we're at 8. 0 to 3, we're at 8. Open circle on 3, closed circle on 0 for x. Between 3 and 6, we're at 6. And we're closed circle here, and open circle there. And between 6 and 9, we're at 4. And it's closed circle there, open circle there. And then that's a step function going down, right? Some of them really look like steps, some do not. Right, domain and range. All right, the domain, the lowest x value is 0, right? The highest x value is 9. Open circle was on 9, closed circle was on 0. That's our domain. That's the possible values of x. X can't be negative here. X can't be above 9. The range is 3 possible values, 4, 6, and 8. And I should write y equals 8. So range y equals 4, 6, or 8. 4 comma 6 comma 8. Okay. Final question. All right, so what was the piecewise function for this graph? Two pieces. All right, so we have a section where we have x greater than 6. We have another section if x is less than 3. When x is greater than 6, y is negative 6. When x is less than 3, y is negative 3. Domain and range. The domain has a gap in it here, but so we said this is an OR, so x could be less than, right, 3, or x is greater than 6. We can see that right here. And then the range is y equals two possible values, negative 3 and negative 6.